that the sum of geometric series is given by the expression a into bracket 1 minus r to the exponent of n, or divided by 1 minus r. Now we know that the sum of geometric series is given by the expression a plus ar, a plus ar squared plus ar cubed plus, and this continue, plus ar n minus 1. So let's call this one equation 1. Now a represents the first term, r is the common ratio. Okay, so now if I multiply equation 1 by the common ratio r, I'm going to have r times Sn equals to ar plus ar squared plus ar cubed. Now basically what I'm doing there is saying a times r, which is giving me ar, and if I have ar times r, right, it's going to give me, this is r times, remember the property of indices, when they both base multiply we add their exponents, so this will be ar to the exponent of 2, because we have 1 here and 1 there, and 1 plus 1 is 2. Also, if I have here ar squared times r, I'm going to have ar to the exponent of 3. So that is how I am getting this expression. So this will be ar to the exponent of 4, and plus this series continue to. Now this last one, I'm going to show you how I'm going to get it. So this will be ar n minus 1 times r. So if I have here to be a into bracket r times r, so this is r minus 1 and this is 1 here, so this will give us a into bracket r n minus 1 plus 1, because when they multiply we add their exponents, and in this case minus 1 plus 1 is 0, so we are left with what? ar n. So if you multiply r by this term, we are going to have ar to the exponent of n, and let's call this one equation 2. All right, now let's say equation 1 minus equation 2. So if I have here equation 1 minus equation 2, okay, see the expression we are going to have here is going to be Sn minus Rsn, which is equals to, now the value of a here is 0, so it's going to be a minus 0 minus a, so we are going to have a. Now in this case we have ar, this is equation 1, ar minus ar, so this is gone, ar squared minus ar squared is done, ar cube minus ar cube is gone. Now the next term for this expression will also be ar to the exponent of 4, so here and here is gone. Also, we know that this is ar n minus 1. Before we get to ar n, the next expression here will also be ar n minus 1, so the both of them is gone. So remember the value of ar n here is 0, so this will be 0, and we are saying equation 1 minus equation 2, so this will be 0 minus ar n. So in this case we are going to have minus ar to the exponent of n. Now looking at the both hand side of the equation, we have common terms, so let's factor them out. In the left hand side, Sn is common, so we say that Sn is factored out, and we have 1 minus r equals to a is also common to the right hand side. We factor a out, and we are left with 1 minus r to the exponent of n. Okay, so we divide through by 1 minus r, 1 minus r. we are going to have here is gone. Okay, so what we are left here basically is Sn equals to A into bracket 1 minus Rn. All this is being divided by 1 minus R. Now, this sum of geometric series is suitable when R is less than 1. So, we can use this equation when R is less than 1. Alright? Okay, now let's also try another thing right now. Okay, so if we decide to take equation 1 from equation 2, what I mean there is by saying equation 2 minus equation 1, what are we going to have here? Let's see. In this case, we are taking equation 2 minus equation 1. So here there is 0 for the value of A. 0 minus A will give us minus A. But first of all, let's write the expression Rsn minus Sn. This will be equal to equation 2 minus equation 1. And as I said earlier, the value of A is 0. So this will be 0 minus A. So we are going to have minus A. And in this case, all those items are gone, as I explained earlier. And in this case, we have ARN minus 0. This will be plus ARN, right? Okay, so this expression can be written as Rsn minus Sn equals to AR to the exponent of n minus A. Okay, now let's factor out what is common to both sides of the equation, Sn, and what we are left is R minus 1 equals to what we have here, A, and this will be R to the exponent of n minus 1. Okay, now if it is by the both sides of the equation by R minus 1, we are going to left with Sn equals to A into bracket R to the exponent of n minus 1. All this is being divided by R minus 1. Okay, and now this equation is suitable when R is greater than 1. So you need to take note of that information. Take note of this. Take note of these two terms. Yeah. When R is less than 1, use this equation. And when R is greater than 1, use this equation.